We think that most of the mass in the universe isn't actually made of normal stuff like you and me. It's an invisible substance called dark matter. The problem is we have never actually seen this dark matter. We only infer its presence because of its gravitational effects. For example, stars at the edge of galaxies seem to be moving way too fast for how much normal matter they have. So we assume there must be some invisible mass out there, dark matter, holding them in with its gravity. This is a problem for astronomers because if they can't see dark matter in galaxies, they can't really study it. So they'd rather see a galaxy without dark matter than one with a lot of it. And in 2022, they might have done just that. In a preprint posted to the website Arxiv, a team of astronomers said they had found 6 small galaxies that contain very little dark matter relative to their amount of normal matter. That's not zero dark matter. These galaxies still need some dark matter to hold themselves together, but the amount seems suspiciously low. If these galaxies are real, they could help us understand what dark matter is. They could also completely upend our understanding of how galaxies form. But first, we need to figure out if they're real. There is a chance that something is wrong with the data or that the measurements of these galaxies' properties are just inaccurate. But let's pretend that all that stuff is totally fine. Even so, we need to talk about the elephant in the room, which is dark matter is supposed to make up most of the mass in galaxies. So, how could these galaxies possibly exist without any of it? To answer that question, we need to talk about what holds galaxies together. I mean, obviously, gravity is the main force at play here. Every object in a galaxy is attracted to every other object. The more massive an object, the stronger its gravity. And the closer an object is to another one, the stronger the gravitational pull between them. So when you've got a bunch of stuff in a galaxy, all of the normal matter pulls on everything else. If you keep track of all those gravitational interactions, you can calculate how fast something in that galaxy has to go in order to stay in orbit around the center. You can also calculate how fast something would have to go in order to escape a galaxy entirely. If something is going faster than escape velocity, then gravity can't keep it in the galaxy and it flies off into outer space. If something is slower than orbital velocity, then it gets pulled in towards the galactic center by all that extra gravity. Over time, all those interactions gradually build up and shape the galaxy. Gravity is always pulling things towards the center, so you need some extra force to stop them from collapsing in on each other. For stars, that comes in the form of their own inertia, or basically their tendency to keep doing what they're already doing. If a star slows down too much, it crashes into another star. If it speeds up too much, it flies away from the galaxy altogether. Normally, dark matter makes up that extra force. The idea is that although dark matter is invisible, it makes up a lot of the mass of a galaxy, so it has a lot of gravity. All that dark matter's gravity pushes back against all that normal matter and keeps the whole thing from collapsing. In a typical galaxy, there's about 5 times more mass in the form of dark matter than normal matter. So there's plenty of dark matter out there to balance out all that normal matter. But if a galaxy starts out with less dark matter, then there needs to be something else keeping it from collapsing. Maybe the normal matter in these galaxies is clumped together in a lot of big stars. Big stars have a lot of gravity. So if there aren't a lot of dark matter particles in a galaxy, then there need to be a lot of big stars. The stars in these 6 galaxies are definitely big and bright, but that alone shouldn't be enough to counteract all their own gravity. There should still be some dark matter in there somewhere. So why don't they see any dark matter? One possibility is that there just isn't any in these particular galaxies. That sounds crazy, but maybe it doesn't have to. After all, normal matter is like the spice of life. It's what makes each galaxy unique. Normal matter is also what makes stars and planets and black holes and all kinds of cool stuff. So maybe what you really need to make a galaxy is a pinch of dark matter and a whole lot of normal matter. In this scenario, dark matter isn't an ingredient that you mix into everything. It's more like an ingredient that you put in some things. It's an enabling agent that allows certain structures to form. If that's the case, then dark matter doesn't need to be evenly distributed throughout a galaxy. It can just hang out in the outskirts, barely interacting with anything. So, if you don't look in the right place, you might completely miss it. But wait a minute, if dark matter doesn't evenly fill galaxies, then wouldn't it just fall into the center of the galaxy over time? Like all the dark matter in a spiral arm would eventually just pile up in the middle of the galaxy. Well, yeah, that would happen eventually. But while the dark matter is piling up, it's probably relatively evenly distributed, or at least more evenly distributed than the normal matter. Stars spend a lot of time crashing into each other and exchanging material, so it's kind of hard to keep track of where exactly that normal matter came from. Dark matter, on the other hand, is invisible and barely interacts with anything, so it's much easier to keep track of. So while a galaxy is forming, it's possible that you would see more dark matter in the outskirts than normal matter, even though the dark matter eventually does collapse into the center. Now, if this were true, you'd expect to see a lot of small galaxies without dark matter because small galaxies form earlier than big galaxies. And when they're small, their dark matter hasn't had time to collapse to the center yet, but we don't see that. So either dark matter is evenly distributed within galaxies, or these galaxies really do have almost no dark matter. Another explanation for these galaxies is that there's something wrong with the measurements. After all, these are really small galaxies. And sometimes it's hard to measure the properties of small things. For example, we don't know exactly how big these galaxies are, and that affects how fast the stars have to go in order to stay in them. Also, we have no idea what's in these galaxies besides the stars. There could be a lot of stuff that we can't see, like dust clouds or black holes, both of which affect how fast the stars go. And finally, we don't know the exact distribution of masses within each star. The average mass of stars in these galaxies might be similar to the average mass of stars in other galaxies, but that doesn't mean that every single star has the same mass. All those uncertainties could add up and explain why some of the stars in these galaxies are moving so slow. But there's another possibility, too. Maybe this isn't a measurement error. Maybe there's a new physics error. Maybe there's some new unexplained phenomenon that's slowing these stars down. Either way, we can't say for sure what's going on until we get better data. Ideally, we want to observe these galaxies over long periods of time. That way, we can track how the stars move and see if they ever start to collapse. It would also be nice to know what these galaxies look like in other wavelengths of light. If there's dust in these galaxies, it'll absorb visible light, making them look fainter. And that could explain why these galaxies look so small. Until then, we lines just have to wait and see whether or not the phantom galaxies turn out to be real. If they are, they'll teach us something new about how galaxies form. If they're not, then we'll just have to keep searching for the missing dark matter. I find it really satisfying to learn something new and share it with other people. That's why I love being a teacher and I love making these videos for you guys. But sometimes I get stuck because I'm trying to learn something new myself, like learning enough algebra to explain the math behind compound interest. I'm still working on it.